Within the topic of common fractions, we are going to focus on square and square roots. We are going to use exercise 13.8 to illustrate these concepts. We are firstly going to consider number 1a. So we have half squared. We know a square means multiplying something by itself. So we could say this is in fact the same as 1/2 times itself. So in fact a half times a half. And then we could say multiply tops, 1 times 1 is 1. Multiply bottoms, 2 times 2 is 4. Another way that we could approach this is to say whenever we see a fraction that is squared, we are allowed to separate. So we could say alternatively that this is the same as 1 squared over 2 squared. So we simply separate them, the fraction parts, into whole parts. So we have, in a sense, the divorce. Here they were together, now they are separate. And then we can say, well, 1 times 1 is simply 1, 2 times 2 is simply 4. So we get to the same result. So I'm going to give you some time to attempt number B by yourself. So if we use the rule that whenever we see a fraction that is squared, we can actually separate the top from the bottom and square each one separately, we have that we should be able to square the 2 and we should be able to square the 7. And now 2 squared we know is the same as 2 times 2, which is 4. 7 times 7 is 49. So we end up with 4 49s. I don't believe we can simplify. 2 can't go into 49 without a remainder. 4 can't go into 49 without remainder. So this is the simplest form. So let's look at number 1C. Okay, so now again we have square of fractions, but this time it's a bit different than in the previous two. This time we have in fact a mixed fraction, not a proper fraction. So we first have to change, as usual, mixed fractions into improper fractions before we square. So how do we do that again? We take the whole number, multiply it by the bottom number or the denominator, add the numerator, keep the denominator the same. And then all of that we can square. So 2 times 3 is 6. 6 plus 1 is 7. So we have 7 over 3. And we can square that now. So now we know if we have a fraction inside brackets that needs to be squared, we can have the divorce or separate the top from the bottom or the numerator from the denominator and square each one separately. So we have 7 squared over 3 squared. So 7 times 7 is 49 and 3 times 3 is 9. I believe this is improper fraction. We have a bigger numerator than denominator. So let's see how many times 9 go into 49. 5 times 9 is 45, so 9 goes 5 times. We have a remainder of 4. And we always keep the bottom part or the denominator the same. So it's the same as 5 and 4 9ths. So now I'll give you the opportunity to try number D on your own. I'll just give you a bit of a hint. You can make the minus either part of the top or part of the bottom. You choose which one you want to make it part of. Okay, so we have in brackets a fraction, it's squared, so we know we can separate the top and the bottoms and square each one separately. I'm going to include the minus as part of the negative 4. You could have used it as part of the 13. You should get to exactly the same answer if you don't make any mistakes. That is now the final answer. So I'm going to say I have negative 4 squared, and at the bottom I have the 13 squared. So I separate it. So now negative 4 times negative 4, negative times a negative is a positive. 4 times 4 is 16. And 13 times 13 is 169. And I believe this is in simplest form. We won't find anything that go into both the numerator and the denominator. Please take note, whenever you have a negative fraction that needs to be squared, it will always result in a positive answer, like here, because a negative times a negative gives a positive. So now that we have focused on squares, let's tackle square roots with fractions inside. So we have a fraction inside the square root, very similar than what we did with squares. If we see a fraction in the square root, we can separate the fraction into the top and the bottom part and take the square root of each separately. So we could say this is the same as the square root of 56 over the square root of 81. So, square root of 56, now we need to work in reverse because a square root is the opposite of the square. So we need to ask, What times what gives 36? 6 times 6. 6 times 6 gives 36. We also need to ask what times what gives 81. Yeah, 9 times 9 is 81. So we are working with pairs that are exactly the same, that we need to multiply with each other to get the answer in the square root. And then it is as simple as we keep one of the pairs. So we keep one of the 6's without the square root. We keep one of the 9's. I believe this is not in simplest form. 3 can go into 9 without the remainder. 3 can go into 6 without the remainder. So how many times does 3 go into 6? Yes, 2 times. How many times does 3 go into 9? 3 times. So this is the same as 2/3. So I'm going to give you the opportunity to attempt number B, 2B on your own. Okay, so we have a fraction in the square root. When we see that, we can separate the top and the bottom and have their own separate square root. Next, we ask what times what, where we have the same pairs, gives 4. So yes, 2 times 2 will result in 4. What times what gives 256? Yes, 16 times 16. So now we can keep one of the 2's, we can keep one of the 16's. This is not simple as form. 2 can go into itself once, 2 can go into 16 8 times. So we end up with 1/8. Number 3C. Now we have a mixed fraction inside the square root. If we see mixed fractions, what do we do 99% of the time? Yes, change into improper fraction. So, what is 3 times 36? Because we need to multiply the whole number with the denominator and add the numerator. So we need 36 times 3. 6 times 3 is 18. 3 times 3 is 9 plus the 1, so it's 108. So we have 108 plus, we need to add the 13, 108 plus 13, well, can even do it like this. 8 plus 3 is 11, 2, 1, 2, 1. So we have 1, 2, 1 at the top, we have 36 at the bottom. So now we are allowed to separate, so we have square root of 1 to 1 at the top, square root of 36 at the bottom. So now we need pairs that are the same, so what times what gives 121? Yes, 11 times 11. What times what gives 36? That one you know well, 6 times 6. So now the strategy is keep one of each pair without the square root. So we have 11 at the top, we keep 1 6 at the bottom. It is an improper fraction, top bigger than bottom. So how many times does 6 go into 11? Once. Remainder 5. At the bottom we keep the 6. So try number D again on your own. I'm going to give you a bit of time. Okay, so we can, again, this minus, it can be at the top or at the bottom. So I'm going to use it at the top so we can split, we can separate. So I have negative 9 at the top and I have 25, the square root, at the bottom. But now we have a problem. We cannot get the square root of a negative number because we can't find two pairs that's exactly the same that we multiply with each other that gives a negative answer. For example, if we take minus 3 and multiply that by itself, a negative times a negative is a positive. 3 times 3 is 9. We don't get a negative 9. So therefore, it's impossible to, at school level, to get the answer for a negative square root. Only those that do maths at university first year level will learn how to do this. So we will say this answer is undefined. So your task is now to to attempt number 3 of exercise 13.8.